All right. Request for a couple of different examples, permutations, conditions. I'm going to go ahead and do that now. And hey, we have so I'll look at first is just a permutation here. There's 7 students in a pizza eating contest, and they want to know the number of ways that the 7 students could finish the competition. So you could have Tom finish first, and you could have Susie finish second, you could have Jill finish third, so on and so forth. Or you could mix it up so that Jill is first, Susie's still second, and Tom is third, and so on and so forth. But there's 7 students, so you need a list of 7 kids and 7 students going this way. So what you'll do is, first of all, you determine, does order matter or not? In this case, since you have a first, second, and third place, order does matter, and so we would use a permutation. There are 7 students, and they're considering all 7 places. Now, if it just said first, second, and third, you would do 7 permutation 3. But we're not going to do that in this case because it's more than just first, second, third. They want first through 7th. So we're going to do 7 permutation 7. Now, an easy way to do this is just 7 times 6 times 5 times 4 times 3 times 2 times 1. You can plug that into a calculator, and it will give you an answer. What I did instead was I went ahead and went to the permutation combination website that's attached to this assignment. And on that, I just plugged in 7 students taken 7 at a time. Now, we don't want a combination because combination means order doesn't matter. And if I put all 7 of them in a line and order doesn't matter, there's only one way to do that. You just group all 7 of them up together. And that would be a combination. That would be if order doesn't matter. But order does matter. So the answer here is going to be 5,040. Once again, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. It'd be the same answer, 5,040. So that's what we're going to get for that particular question. Let's go ahead and move on to another one. I'll pause here for just a second. And go. The next one is find the number of different 5-person teams that can be made from 20 people. Let's say I have 20 wrestlers in the room, and I want to break them up for a workout. So there's 5 in this group, 5 in that group, 5 in that group, 5 in that group. But I want to know the number of different ways that I can put those kids in those 5 groups. Now, a group of 5, does order matter for that particular group of 5 kids? If I pick one kid, does he get more importance than the second kid or the third kid or the fourth kid or the fifth kid picked? No. So in this case, order does not matter. Does not matter. And we'll use what's known as a combination. Since we have 20 students all together, we'll do a combination of 5. The math on that's a little bit more tricky, so I'm just going to go ahead and go to the website, put our number of students in, and the number we're going to pull them from would be next. All right, in this particular case, we have 20 students all together, taken 5 at a time. Order does not matter, so we're not going to choose a permutation. We won't have 1 million different outcomes. But there are 15,504 outcomes here. So this would be 20 combination 5. Gives us 15,504 different ways that I can put those wrestlers in a group. All right. Now, in that question, order didn't matter. This one that we did, order did matter for permutations. And that's the big difference. We just use the and plug those in.